So I'm going to introduce our next speaker that was Amanda Barney. She had last time a problem in the last hours and she was not able to participate, but she kindly invited to give her presentation to Chris Rodley, that is the CEO of Snapit, a company from New Zealand. He's a colleague of her, and he's to present electronic monitoring for fisheries and delivery of AI analysis at scale. I want to thank Chris Rodley because it was a very last hour in the last minute involvement, but thank you, Chris, for attending the forum, and please go ahead.
Hey, thank you so much. Can you see my presentation?
Yeah.
Wonderful. Hey, thank you so much. Good evening for me. It's quite late. It's almost the morning. It's almost morning in New Zealand, but it's lovely to meet you all. Teem Fish Monitoring is a Canadian-based electronic monitoring company. We install cameras on fishing boats around the world. We have cameras in Europe and France, North America, Canada, the US, Australia, Hawaii. We've done work in the Pacific. And of course, we also operate in New Zealand. So we have hundreds of pieces of hardware installed around the world. I'm not Amanda Barney. I'm Chris Rodley. Amanda Barney is the CEO of Teem Fish. She has extensive experience working in fisheries management and running a technology company. She's a much better speaker than me, so forgive me for stepping in. My name's Chris Rodley. I'm the chairman of Teem Fish Monitoring. My company, Snap Information Technologies, acquired Teem Fish Monitoring last month. We had our first board meeting this morning, and we're really excited about this business and what it's doing to see transformation in fisheries around the world, and specifically what it's doing with AI and machine learning. So as you're probably aware, basic EM components, you guys in Europe call it REM. Data capture is really key, and it's important to have robust cameras and to have good vessel-specific catch handling practices. So for us, a key part about what we do, because our data has been collected to replace onboard human observers with cameras at scale on hundreds of vessels, it's really important that we have good catch handling practices and good relationships with crew on all of the vessels that we operate. We also have an electronic logbook system that we deploy. So we're able to collect a number of different data sets in our use cases: electronic logbook, GPS positioning, various sensors on board the vessel, as well as visual imagery. Data retrieval is really key for us, especially when you're operating at scale. So one of the challenges is how we get the data off the vessel. Traditionally, hard drive swapping has been utilized, in other words, handling a physical hard drive. However, we also use Wi-Fi, long-range Wi-Fi and cellular for transmission of data at scale, which has been really successful. And then data is stored in, generally it's stored on an Amazon bucket and is processed as part of that storage facility, and we can process AI either in the cloud or on the device. Data analysis is a real key. We have a team of human reviewers who watch video from fishing boats all day, every day. It's really important in our business that data is collected, processed, and then submitted for federal or government regulation in a timely way. And our target is, in some fisheries, is 8 days. So it's very tight. It's really important that it runs smoothly and continuously. And also security is really key. A little bit about me. We build our own cameras. Our cameras are built utilizing the NVIDIA platform. We use the TX2 or the Xavier or the Jetson Nano module. But we have a custom board that we've designed in-house that allows for M.2 NVMe storage, so a significant amount of storage. We can store an entire season on the camera, entire season of fishing. and we also have cellular connectivity built into that board as well. Analysis is really key. Currently in our storage array, we're storing around about 200 years of continuous video from fishing boats that's growing on a daily basis. And all of that, or the bulk of that data, so significant amount of video data, has been annotated inside our software system, so we can actually annotate and train and create a continuous improvement loop inside our review stack. So as our human reviewers are watching the video, they can train and retrain the AI to just ensure that continuous improvement element. The key part for us is the connect part, which is taking where are we going to put the interpreted data. In other words, where are we going to submit that to industry for the business intelligence, or are we going to post that to a government database for compliance purposes? And so for us, it's about how we move from the collection of really good data right through to that submission element. Two things that are really key is getting 100% coverage of fisheries is possible now. So as we see scaled rollouts happening possibly in New Zealand, in the US and in other markets, Chile and around the world, we're seeing the ability to actually review 100% of all fishing activity on every vessel. So that's a huge, huge problem. And the bulk of our effort goes into how we can reduce the amount of data that's watched by a human. What we like to say is how we can make humans superhuman using AI. And that just results in smaller videos and fewer files that's stored and collected. I can't share a lot of data because it's extremely secure, so forgive me. In this project, I'm not allowed to share any data. But we did a New Zealand longline trawl fishery in 2018, so we've been doing AI for a long time. In 2018, we were able to utilize AI and computer vision technology to reduce the amount of video that the human reviewer had to watch by 98%. So a really significant margin, and allowed for one human reviewer to review 30 vessels a day, which was very significant. And that was in a trawl fishery. We've worked in Hawaii on the Longline fishery, designing AI and utilizing AI to allow for catch differentiation, so we can begin to, this is an early prototype, but we can begin to identify individual fish and begin to do work on species recognition as well in that case. Recently, we have designed a basic, very, very basic discard detection AI. So the key is identifying when a fish leaves the vessel, and then using that, highlighting that to the human reviewer so that they can find those key moments inside our review platform. And this is an early prototype that I'm allowed to share. It's really important to note that the fisherman here is obeying the rules of this fishery. And this is actually what he's required to do, this type of discard. But it's very significant to be able to share a clip like this. Normally these clips are extremely sensitive. We have worked with monitoring recreational fisheries as well. So in this case, we installed a camera on a restaurant looking at a cut at a channel in Alabama. And the idea was to monitor recreational fishing vessels and identify so that scientists could estimate the amount of red snapper that was being caught in that fishery by looking at the frequency of recreational boats and as they came and went in their direction. So we designed a training system that allowed for that data be trained, and then a submission system that created a database that was utilized to create an assessment of that fishery in the season. What we want, the reason why I'm really excited to talk to everyone here today is we see there's so much AI work for us. We have far too much. And there's too much to do. And so we've tried to build a system that's really flexible, that allows for the creation of the allocation of some of our footage to third parties so that they can create solutions for our customers. And one of those solutions and one of the initiatives that we really want to establish that we'll be working on establishing in 2022 is the creation of a marketplace that allows for AI to be shared between nations and between fisheries, as well as creating a way for AI companies or academics to pick up existing tools and create incredible things with those tools and then share their work and even create a commercial value from that work. So I'm really interested in talking to any groups who are interested in more details about that and how we might collaborate. We think the key needs for progress in AI to get it to scale is trust. It's really important that governments are able to compare human review results to AI results, and that allows for the building of trust in AI and obviously a huge cost reduction. We're excited about the current season and how we can see scaled government projects because of the effects of the pandemic on fisheries monitoring and management and the need now to adopt new methods for fisheries monitoring. We're also excited to see an increasing blue tech VC investor marketplace for businesses who are stepping into the space. My company has raised money 3 times, and there is money available now to address blue economy concerns that I think is really interesting. And then, as I said, the development of the marketplace I think is really key and will allow for cross-pollination between nations. I'm Chris Rodley, so feel free to email me or Amanda. Apologies again that she wasn't able to present. She's much better than me at presenting, but thank you so much for your time. I really appreciate it.
SICAPTOR, monitorización electrónica para una mejor gestión.